just fine. The axis. I'm gonna run that all the way down. I'm about to do something wild. Okay, so the spindle runs on 120 volts AC, 3-phase, generated by this VFD that's on the back. And that is plugged in straight into 120 volts AC there. The control system is completely electrically separated from this spindle and is plugged into the same circuit, but otherwise is electrically isolated. But yet, when I turn on the spindle, the axes move. And what's really wild is this thing. This tool is used, it's a tone wand, it's used in tracing wires by sending an electrical signal down the wires at a particular frequency. And side benefit is that it will pick up electromagnetic interference in the air. I'm going to unplug the controller so that I can't move any of these motors this time. And when I turn this on to pick up sound, you can hear electrical noise, like fluorescent lamps produce a particular amount of electromagnetic interference. And you can hear it kind of in space here. But when I turn on the spindle, just the electromagnetic interference as the spindle is speeding up here, the frequency of this interference is increasing very slowly. Wow. There we go. Up to 400. I guess the actual speed of the spindle is 24,000 hertz, which is probably what that pitch is, 24,000 hertz. And the great thing is, it's all parts of the frame here are producing this interference. So as I spin the spindle down, you can hear that frequency go down until it cuts out. And we're left with just the background radiation again. So what's happening, what's causing the motors to spin, is that electromagnetic interference is inducing a current in these control signal wires, turning them into basically an antenna, and that control signal is being interpreted by the stepper motor drivers as a signal to spin the motors at some particular rate.